Hello and welcome. We're excited to have you here. As people come in the back, we'll just let them in, and we're excited that they're coming. So you're in the data science machine learning track. We are on the From Analytics to Data Science presentation, and this is really about leveraging Domo across a small team and leveraging the solution to do an employee turnover use case. So it's HR data. We're excited to have you with us. Along with us today, as I am going to do these introductions, we have John Paul Bochman, a consultant in people analytics from TripAdvisor. You might have seen him on main stage earlier today. We're excited that he gets to go in more depth with you all here. We also have joining me, my name is Richard Eddy. I'm a senior technical consultant and data architect for Domo. We have Vishaka Shenoy here with us as well. She's a technical consultant and data architect. And Christy Rowley, a principal consultant and data scientist here at Domo. So the three of us are going to be walking you through the use case and our engagement with Jean Paul. We were also helped by Kurt Fagerberg, but he was unable to join us today. But we do want to recognize that he was a critical part to our engagement. And without further ado, I'll turn the time over to Jean Paul.
Oops, we got it back. All right, so while I explain this disclaimer to everybody in the room, I'd like you to just imagine the Law & Order SVU sound playing. But what we're talking about today is actually a really confidential subject matter. So unfortunately, we're not able to share any of the actual details from our own use case, because it's super confidential stuff. We're talking about people and turnover. So although inspired by a true data science initiative, the data included in the following presentation are fictional and do not depict any actual persons or events. It's coming out of a completely separate Domo environment, and it's going to reflect some of our use cases, but with a little bit of changes and using not the exact examples that we had. I'd also like to take this moment to call out Christy for her excellent grammar, because she's using data in the plural here, which not everybody does, and that's super important to nerds like us. Thank you. So as we go through this presentation, I want you to keep these three things in mind, because they're going to come up over and over again, and they're maybe the three most important parts of our data science initiative. The first one is start with the right question. If you're not making your question an actionable, solvable solution, then you're not doing yourself any favors. I think everybody in the room and probably everybody at this whole conference feels like they need to do data science and machine learning. And the truth is you do. But you can't just do it for its own sake. It has to be a means to an end, because you're going to want to accomplish something at the end of any data science project. The second thing is set aside time to learn. As you hear about our actual use case, you're going to find that the biggest takeaway for me was all the information that I was able to get from this awesome team, which I wouldn't have been able to do at such an accelerated rate without taking 4 months out of work to go take classes all day. And the last thing, as you'll see, we're being a little bit redundant here, but it's data prep, data prep, data prep. Did we mention data prep? The cleaner your data is, the better your results are going to be, and the more time you're actually going to save in the long run, even though it's going to cost you a little bit more up front. We found that we thought our data was really clean already, and it was for our descriptive analysis use cases. But when you start moving into a data science environment, you're going to find that you're going to need to do a whole nother level of cleansing. And if you're crazy like us, you'll actually enjoy that, but you probably won't. So like I said, we want to start with a meaningful question. But what does a meaningful question actually mean? Well, it means you're establishing a business context. So what is the underlying problem that you're trying to solve? Or what's the underlying solution that you want to think about? Have that in mind before you even start the project. And then, like I said, it needs to be actionable. If you don't have a question that can be answered, It's not really a question. There's no room for rhetorical questions in data science. And you'll find that on your own if you make the mistake of actually going forward with an ambiguous project. The next thing is, OK, that's all well and good, but where do I start? You want to start with the solutions that you've already brainstormed. If you heard me earlier today, I mentioned that our team had a lot of anecdotal evidence, our broader HR team. They sort of had some ideas about what caused turnover or what improved retention. And some of them turned out to be right, some of them turned out to be wrong. But that's a great place to start, as long as those solutions are testable. And then, of course, one of the most important things about a business question, and this goes well beyond the world of data science. This is something you're probably already doing, to be honest. And that's, you want to guide, but you don't want to prescribe. If you're asking a question, it can only be answered one way, then you're not actually challenging yourself. And if you're not challenging yourself, you're not empowering your end users to solve a problem. So we knew that we wanted to undertake this potentially huge project. So we sat down and we thought about all the different possible solutions that we could use. The first one was a software solution. So you may be familiar with these. It's like an application that you can purchase. And I talked a little bit about this earlier as well. So apologies if any of this is redundant. But I think it's really important stuff to cover. So a software solution, it's an application you can layer on top of Domo. Or it's something that you pull your data out of and put it into, and then you go do something else with it. And these things can be really good for some use cases, because you can hit the ground running. They're really fast, typically. Once you implement them, you can feed it data, it can spit out an answer, and in some cases, that may be really good for you. You also don't need a PhD. Luckily, we had Christy, who is one and is awesome, so I'd recommend getting a Christy if you could over a software solution. And of course, these tend to be visually appealing. They look nice, which also good for your end users, right? But unfortunately, there's a lot of reasons that that solution just wasn't going to work for us. For one, they cost money. We're already paying for Domo, which is a great business intelligence tool that we already love and know how to use. So do we really want to go spend something else, try something new that we don't already have a great relationship with the vendor? Probably not, right? And I think the most important piece of this is that they tend to be a black box. And by a black box, it's like on the airplane. It's locked in. You don't know what information is hanging out behind that. What algorithms are they using? Do I know I can trust them? And we were talking all through this project about, we are talking about human behavior that we're trying to predict. Predicting human behavior is really, really hard. If it was easy, everybody would be doing it, and we'd probably live in a really fantastic utopian world. But we don't. So we knew that we needed a solution that we could investigate and that we could trust, and more importantly, that we could explain why we trust it to our end users. So as you can see by the little dot there, this solution was just a little bit too small for us. So what's another possible solution? Well, let's just hire a bunch of people, and they can do all the work. And then I can do all the just regular descriptive analytics. They can do all the data science. It'll be wonderful. That gives us a ton of flexibility, right? Because then you got somebody 40 hours a week, all year long, except when they're on vacation. And they can just be doing data science and doing the maintenance on our data science projects all the time, right? So as you can see, the cons here are it's never going to happen, right? If you're in a small analytics team, you don't necessarily have the flexibility to just go to your CEO and say, hey, can we hire 10 really expensive, really smart people? Your CEO may not like that, especially if you're in a function like HR where you're not customer-facing, right? And we don't necessarily want to do that either. At our company, we pride ourselves on agility and speed. That's one of our huge mottos is speed wins. And taking the time to hire a bunch of people, retaining them, making sure that they learn our business, that's just not necessarily the right solution for us because it's way too big. So where did we end up? We ended up with what I call the TripAdvisor solution and what everybody else is probably going to call the Domo solution. I recommend you call it the Domo solution because if you go back to your businesses and you call it the TripAdvisor solution, they're probably going to think it has something to do with your expense reports for this conference, and just avoid the confusion altogether. So why did we do this? Well, it's the opposite of all the things I talked about before in the solutions we didn't end up going with, right? In this solution, I learned how to fish. So that means that I'm not a data science expert. I don't have the PhD, but I do have the analyst skills, and a lot of those skills are actually portable to data science. You're not going to be at the same level that somebody who's been doing it their whole career is, but if all you need is just a little bit of skill, and then you can kind of take it on your own from there, then this is a perfect solution for you. And believe it or not, the step from data analyst to kind of mini data scientist is really not as hard as you think it is, especially if you have great people to learn from along the way. So this was also a customized solution. This wasn't a piece of software that like 1,000 other customers are using. This was a solution that was just for us, and it was tailored to our business needs. And almost the most important part is we had dedicated resources along the way. So for the last few months, it's honestly felt like these guys work at TripAdvisor. In fact, there was a small mistake in one of the pamphlets earlier where they're actually listed as TripAdvisor employees. They are not, but it certainly felt like it over the last few months. So it's not there's going to be cons to this solution too, right? So you're going to have to be willing as an analyst or as a team of analysts to put in the time and effort to actually learn what you're doing and to build the solution itself, which you'll hear quite a bit about. The other thing that I've listed as a con here, but I'm not necessarily sure it is that we broke new ground with this project. The idea of taking our existing partnership with Domo and building it into an even stronger relationship than it already was, and having that embedded data science team with us, that felt like a new idea, right? Because in the old world, you had your data architect, you had your data analyst, you had somebody on your team with the business skills who could translate that back to your end users. And then you had your data scientists. So that wasn't going to work for TripAdvisor, because like I was introduced earlier as an army of one, I have to kind of wear a little bit of all those hats. And that's a new model that I think is going to grow more and more popular with time. So I don't want to spend too much time talking about the initiative itself, because these guys are going to talk very extensively, and you're going to see a really cool demo with some examples that are really similar to the stuff that we did. What we did do was prepare all of our data, which takes a little bit of time. Like I said, you want to do as much preparation up front as possible. You want to assess your data. You want to analyze your data, review your data. And then the most important part is you have to implement that solution, and then you have to hand it off to your end users. And that's where Domo is probably the coolest solution, because they're already going to be used to it, right? You're not showing them something they're not already familiar with. But the most important part of all these boxes is that all 6 of these things have one thing in common, and that's that it was a collaborative process along the way. It was an opportunity for them to learn about our business and our business needs, and it was an opportunity for me to learn the skills that they had in the world of data science. And that, I can't emphasize enough how great that part of the process was. So I do want to spend a second here talking about establishing a data profile, and you're going to see an awesome example of a data profile later. But just the idea of taking your data and looking at it in a new way that's going to change how you think about every field that you're using, and translating that into a data science example, it's not just going to give you data science, it's also going to improve your existing descriptive analytics. We were able to find so many cool little theories along the way that we were able to test and bring back to the business that weren't even a core part of the project. For example, we found that there was one attribute that employees had that if they were promoted into a manager rather than hiring as a manager, they were actually a little bit more successful. So I was able to bring that example back to the business, and they're like, oh, that's really cool. We could do something with that. So right here, you just see a sort of a quick before and after, right? That's what ugly data looks like. That's what clean data looks like, right? You don't see any missing bars there. You don't see any missing states. Super simple. So one of the most important parts of this for somebody who doesn't have those highly developed data science skills is determining the right analytic strategy. So what we ended up doing was testing about 8 to a dozen different models that we knew were kind of going to be the right fit, because there's so many different models out there in data science that have very specific applications, and they may not always be the right one. So where we landed was a regression model. So what that did was it improved our ability to go back to the business and explain what our results were. What I mean by that is when you're choosing a model, obviously the most important thing is that it's accurate. You don't want to pick a model just because it's cool and it gives you results that you think are what you want, what people want to hear. But that's not the end of the story by any means. What you really want to do is have a model that is meaningful to your end users, because you can't expect them to be as data literate as everyone in this room probably already is. That's not their job. They've got other stuff to do. And that's particularly true in like an HR function where people are worried about people, not necessarily data. They rely on me to do that for them so they can kind of translate it into a people solution. So we use the regression model because unlike a classification model, which would just tell us maybe this employee is going to terminate, maybe they won't, the regression model was an overtime model. So it said, hey, maybe this person's going to leave in the next 6 months, or maybe the next year, or maybe the next 3 years, or maybe sooner. That's something that the business could understand really well. And of course, one of the coolest things is now we have these models that live right in Domo. And the difference between a solution that's in Domo and uses data science tiles is for someone like me who's a small, agile team, and I'm not talking about my height necessarily. I know I'm not the tallest guy in the world. For someone like me who's learning all these new skills at an accelerated pace, I need to be able to do that work, and you probably need to be able to do that work in an environment that you're already familiar with, right? So I can go in here, and it looks just like Magic ETL. So it was a little bit more comfortable and familiar for me. Of course, your data is only as good as your validation. This is an area that we also spent a lot of time on. You'll see a little bit more of it later. Unless you're like a complete mad scientist like we are, you probably don't like or care about it that much at this point. But we'd be happy to answer additional questions later on about validation, because we think it's a really cool subject. And the biggest takeaway of all, and this is, you guys probably already saw this earlier this morning, but now we have a dashboard that we can deliver to our customers, and it looks just like what they're already looking at, right? You know, Christy gave me a really great example during this project where she said to me, you know, someone asked me, what does a data science dashboard look like in Domo? Well, it looks like a dashboard in Domo. It doesn't look any different. It's super familiar to your customers, and for them, that's going to be the most important thing. It can't be some like new third-party system that you got to train them on and teach them about. No, just have them look at what they're already used to looking at, just telling them something a little bit different or a little more interesting. And of course, you saw this earlier too, but it's, you hear a lot in data science about how we have to retrain models. And I hope we have to retrain the model really soon, because if we've implemented the solutions that we've learned from our data science initiative, then those actual levers, we're going to push and pull on them until we actually do increase retention. But that doesn't mean it's the end of the story, right? Because, hey, let's go a little bit further. Let's get better and better every time. So as our model becomes less and less accurate because we're making changes, Domo can actually physically alert us to tell us when we need to retrain the data, rather than having to sit there and research or try to figure it out ourselves. And that's totally awesome. All right, so we're going to do a live demo with the Domo team, and then we'll have some questions and a wrap-up.
Thank you, John Paul. And if we can, yep, perfect, great. Okay, so what we wanted to do was to show you what actual HR data might look like inside Domo. Now, this is all fictitious data, and in no way is it related to the TripAdvisor data, but a lot of the screenshots that John Paul was just showing were not HR-related screenshots. But there were a lot of lessons learned along the way, and we thought that highlighting some of those lessons in this kind of abstract HR data way might still be very useful to you. The first thing that you're going to get with a Domo engagement on data science is a standardized 26 questions about what is your scope and what is your use case. This helps us to better understand where does your data live today? What's the kind of data that we're going to be dealing with? What is the business question that you're looking to solve for? So as we do that assessment, it helps us with the output of that assessment, and that is this data science metric map. The data science metric maps helps us to know what is your dependent variable, what are you trying to predict, and then what might be some of the predictors, in other words, the levers that we can pull, or the control groups that are going to provide insights. And in this case, with HR data, our dependent variable that we're looking at is total active months. So that might be, say, today's date or termination date back to start date. And then we determine that maybe a couple examples of predictors would be the number of job profiles that an employee has had, their most recent employee rating, what is their base employee compensation or their bonuses. Then a couple control groups could be possibly age, gender, or race and ethnicity. When we begin to profile the data, we are going to look really at almost every field. The intent is that you're going to have a table of data. Generally, we want to have one single data set, and every row in that data set should mean something. It essentially should be indicative of whatever it is that is your unit of measure, whatever you're trying to measure. And then all the columns related in that data set are going to be control groups, predictors, etc. So this top card looks probably like a lot of your HR data. For example, employees who are here 3 months, 8 months, 13 months, etc. Moving to the right, you're going to have more employees that have been here a little shorter, and it skews right as you go along with the number of months. One thing you're going to have to ask yourself really early on is, what are those important predictors? Now, in this case, we figured that employee rating would be a good predictor of an employee's likelihood to stay or propensity to stay. However, we found that in our fictitious data that we were only measuring their employee rating once a year. So if you're really only measuring employee rating once a year, but say you have terminations by month, is that on the same level of grain? And it's not. So as you determine what are your important predictions, or what will be important to your prediction, you might look and say, well, my unit of analysis that I thought was more granular actually needs to be rolled up. In this case, we rolled it up to the employee level. So we didn't, for example, take in every assessment or every rating that they ever had. We took the last rating that they've most recently had, and we applied it to the employee file. So we ended up with, let's say, 7,000 observations of employees, and then their most recent rating. Now, as you profile your data, you'll likely encounter a spot where you end up with null values. These missing values are very hard to predict on. You can do a couple of things. You could impute the value of those missing fields, or you can also profile the data and see just how prevalent the missing fields are. And in this case, we had 15 cases where an employee had either chosen not to disclose their gender, or we had 15 cases in which maybe they're so new to the company that they just haven't had time to enter that in. So when we looked at this data set and its profile, we determined that just ignoring these null values would be an appropriate step for us. So the other thing that we can find with these categorical variables, as you're trying to cleanse and prep your data, you might find that you have categories with long tails. And in this case, after about the 5th bucket of race or ethnicity, you end up seeing lots of very small numbers as that tail continues down. Those smaller numbers don't end up with a lot of predictive value. The number of observations is too small to really be able to say, this looks like and feels like every other employee at the company. And so an approach to this is to essentially group them up into a bucket of other. And that group of other provides you a smaller data set, smaller as in there's fewer categories that you have to deal with, and it also actually does provide some predictive value to the group of other. That group of other can tell you something about those groups and can still be part of your prediction. So you might, especially for some of more advanced data scientists in the room, you might look at this chart on the left and say, there's a concern here. You have a strong colinearity between the number of count of job profiles and your dependent variable. They skew the same way and strongly. And yes, you can probably assume that somebody who has only been at the company for 3 months has one job profile. So the concept of centering is an appropriate way to deal with colinearity. And instead of centering on the mean, in this case, what we did is we said, for the amount of time that you have been with our fictional data company, how many job profiles do we expect you to have? Are you at that expected number of job profiles, or are you below or above? And you can see that the shape of your data changes when you approach it in that way, and that allows you, from this centering perspective, to use this as a powerful predictor instead of a too closely correlated predictor, as the one on the left shows. Now, you're dealing with HR data, and you know your company, and you're saying to yourself, oh my goodness, half of my data is garbage. Why is it garbage? Because we switched the way that we measured our employees 2 years ago. So I've got 4 years of employee data, but we were on, say, a 3 or a 5-point scale, and 2 years ago we switched to the other scale. So you might say to yourself, how am I supposed to mesh a 3 and a 5? Well, it's a valid question. The first part of it might be, was there a substantial enough change at your company when you made that change that truly your data is garbage? Like, it's not worth evaluating what happened so long ago because it's no longer indicative of what's happening at your company today as far as employees go. If that's the case, then you've essentially got your business answer there. However, if you feel like the employee rating scale changed, but it still is representative of your employees for today, you might look at ways in which you could merge these two data sets. Now, if you look at the distribution of the data, and if you look at the size of the data, you might say, well, those look like we might be able to merge those together. When we did a deep analysis on the 3-point rating scale, we actually found that due to rounding, items that had received something like a 1.5 or a 2.5 were being forced into these 1, 2, and 3 buckets. When you discover that the rounding has occurred, then reversing the rounding, essentially going back to the source and finding out what those were, actually lends itself into a 5-point curve distribution. So we were able to, as you see on the card on the far right, merge a 3 and a 5-point scale together. Last little example we have as far as data anomaly you might encounter. You might have, say, 7,000 employees in your record, and in this case, we modeled 63 employees that had left the company and had come back. So these return employees or boomerang employees, take, for example, employee A at the top. This guy's going to have 2 start dates and 2 end dates. That, if it shows up as 2 records in your data science data set, is going to have, you could say, double the influence as it should have on the predictive value. Likewise, employee B, 2 start dates, 1 end date, 1 null. So pay attention to places where even the cleanest data, you might find something and you say, oh, I should have thought of that earlier, I didn't notice that before. At this point, it really comes down to a business decision. Do you want to take the first start date to the last end date for an employee like this? Or do you want to say, hey, we understand what's going on here. We really just want their latest event for our company. So these are the kinds of anomalies, distribution profiles, et cetera, that you're going to find as you go column by column through your data, both across categorical variables and numeric variables. So that's what primarily my portion of this engagement has been. I'm going to turn the time over to Christy for some model selection and descriptions there. Thank you.
Thanks, Rich. All right. Of course, the first thing that we want to do anytime we're talking about models and model selection is setting a baseline. So before we even start talking modeling, we're going to determine what the organization, in this case our fictitious company, is doing to measure what the baseline accuracy is already. In this particular case, the company had very little idea what turnover was going to be like. They knew what average turnover was for years or months. But in terms of actually predicting which employees were going to turn over, that was a little more difficult. In this case, the best way to set a baseline is to take your best measure of central tendency, set a parameter around that, and that's your baseline model. In this particular case, you can see our baseline model accurately predicted 33% of turnover. We could do better than that. We can definitely do better than that. However, it's really important to set a baseline because anytime you're communicating things about data science to a stakeholder or executive sponsor, you need to communicate that you're never going to predict 100% correct, ever, not ever. If you do have a model that's 100% accurate, it's probably wrong. Or there are probably a few other problems that are generating that kind of a result. So we want to know what we need to, we're not shooting for 100%, so where are we shooting? In this case, above 33%. And you can see on the right-hand side here, our predicted model is at 72% accuracy when we test our training data set against a validation data set. In terms of validation, cross-validation is always very important. There are several methods for doing cross-validation. After completing 3 different versions of cross-validation, I went with the easiest one to understand and interpret, as the 3 different types of cross-validation did not significantly yield different results. So in this case, we went with a training validation split. So we took 80% of the training data and used that to train a model. 20% of the data were withheld from the model, and we tested the output of the model against the accuracy of what we knew was true for the validation set. And in this particular case, you can see all of our different validation metrics. We have an R-squared, an MAE, and RMSE, several other versions of cross-validation, several other metrics up there that you can take a look at. You'll also note, and Domo is one of the rare places that I believe you can do this, so it's worth highlighting. You can see here in our first row, this model was trained on the 1st of January of this year. It was trained again in February. It was trained again in March at the 1st of every month. In this particular case, you can set up a recursive data flow to add a new row every single time you train. You can then create a summary number. And if that summary number changes by a certain amount, you can set an alert to alert you and tell you to go in to retrain the model or revisit the model or take a look at it. Because you know something is different and has shifted significantly from what it looked like before. Also because we're working with customers who are learning data science or have stakeholders that are learning data science and may not always understand all the terminology, we have a dictionary right here to help with that. Of course, to avoid situations that may arise with a black box solution that Jean-Paul has talked about earlier, we want to show exactly what's happening in that model. As Jean-Paul mentioned earlier, we ran between 8 and 12 different models, checked them all out, looked at them, made some strategic decisions about which one we wanted to look at, and you can very easily build a demo card around that and have all of that available to you. Also, a dictionary to help you know how to use the model and help you know how to interpret it. One of the great things about Domo as well is you can take a look at all of the scores in the model, and as employees turn over, as ones who you have predicted would turn over actually do turn over, you can check the accuracy of those predictions and monitor them over time. So in this particular case, from January 1st of this year and through yesterday, we had a number of employees turn over in this fictitious company. They all had predictions. We know if we overestimated those, if we underestimated those, or if they were correct. In this particular case, overestimating is far more tragic than underestimating. If you underestimate, you can still run an intervention. If you overestimate, you can't. You run out of time to do any kind of intervention. Ideally, what we'd like to see is these summary numbers right here. You can see the percent correct, percent overestimated, and percent underestimated. We'd like to see those represent these. And if over the course of a few months, they're not very close, that's another sign that you might want to go back and retrain the model. So Domo makes it very easy to have a complicated dashboard about data science and about your data science models. Very easy to access, quick to take a look at, and see where you need to do some more work in your data science models. All right, now the fun part. This is the part that everyone does a data science engagement for. They want the dashboard at the end. So if you're looking at employee turnover, who is going to turn over and when they're going to turn over is one of the most important questions. We also have another question as to why they're going to turn over. And finally, what can we do about it? And we have cards here that will address all of those issues. The first one right here, I will click into it and show you in more detail. We have employees that are going to turn over or anticipated that they will turn over this year. You can see this employee at the top is anticipated to turn over today, and then these are ordered by date from today until later on in the year. We also have color coding. This is a heat map card. We have color coding to indicate the amount of time that you have to run an intervention. So the red ones up here, you don't have very much time at all. Orange ones, you have a little more time. And then the gradient descends until you have yellow down at the bottom. You have as many as, I think, 8 months for this group. You'll also notice that we have grayed out names here. And these two folks here at the top are going to turn over relatively soon, or at least they're predicted to, but we've grayed them out. They're not highlighted in red or orange. The reason for that is you'll notice that their last performance ratings were not very high. And in talking to our stakeholders at this fictitious company, of course, they have talked to us about these are the kinds of employees that we will want to mentor out of our system, or we'll want to manage them out of the organization and not necessarily try to keep them in. This is generally a sign that they're not thriving where they're at. So we may not want to put a lot of emphasis in staging an intervention for these particular employees. Now, in addition to a great intervention dashboard, which we have here, we've also got resource planning dashboards and the opportunity to look at resource planning as a whole. So you can see here that our technology sectors, sales sectors, and finance sectors of this fictitious company are at the most risk for turnover in the coming year. As a result of that, we may want to allocate more resources. We may want to start looking at resources differently in a way that we can help them. We may want to start thinking about interventions that we can run in those particular sectors specifically. We also have information about who needs immediate interventions. We see 1 employee in marketing, 2 in product, and 1 in finance. As we saw from our previous dashboard as well, those 2 employees on the product sector were 5. They had a rating of 5. That's the highest performance rating in this particular analysis. We want to keep them. We really want to keep those particular individuals. And so it might be worth investing some more resources in that product team to see what we can do to hang on to some of our most valuable employees in an important part of the business. Knowing why they're turning over is also useful. And given the kind of model we built, we can use standardized coefficients and identify what kind of interventions we could stage and what the expected amount of months increase in their tenure at the company that should yield. Even more exciting than that, we can do what-if analysis and scenario testing with a very cool app that Vishaka built especially for this product or project. Thanks.
So once we got our results here, we wanted to see what sort of interventions we can take or what sort of levers we can pull to influence the outcome. And in this case, it was what can we do to make the employee stay longer. As Christy pointed out, there were 3 individuals up there who had a rating of 5. And since we trust our performance rating, we wanted to keep them because they're highly skilled and they're smart. What we did to do that in a highly user-friendly way is build an app on the model outcome. We did this using Domo's Dev Studio, and we used the variables that we know we had a control over. So let me run a demo of the app. So let's say I want to analyze by the performance rating, and I want to see how equity grants, base pay, and bonus percent affects the outcome. Now, if you recall, our unit of analysis is an employee, and we are trying to predict months until turnover. Now here, you can see right off of the bat how each employee that falls in each performance rating bucket is predicted to turn over. And these are the average values that were plugged in, but let's say I want to see if we bump up their equity grants by 100. And the 3 examples that we saw would fall in this bucket here, the 5-point rating. And we can see that we got a few months right off the bat. Now I want to see how the other variables affect this. If they are at the 3.5 base pay % increase, I want to see if I bump them up to 10%, what happens. We did get a few more months, but not as much as what equity grants gave us. So let's switch it back. 4 is good. Let's try this. By giving them 10% bonus, does that make a difference? It does, but not as much as equity grants. So by this what-if analysis, we can see how much of an effect each variable has on the outcome. This is just a user-friendly way of seeing how each variable will affect the outcome and at what scale. By doing a cost-benefit analysis, we can figure out if we want to use a combination of these variables or just one variable and see what we can do to make the employee stay. Also, in a separate analysis we also found out that an employee that has switched more job profiles than expected is expected to stay a few more months than someone who hasn't. So this is just makes it really easy and visual to see how the outcome is affected. I'll turn it back to John. Can we switch back to the PowerPoint?
Sure. All right, so in the last couple minutes here, I said this earlier, but I can't say it enough. I actually stole this quote from Christie. I'm not sure if I gave you credit the first time, but share with your friends that this is a Christie quote, not a Jean-Paul quote, but I might steal it in the future. Data science is never done, it's only due. So that's why having this partnership was so critical to our initiative, because we can't just have a solution that ends on day 50 or day 60 or whatever, and then we're left alone in the dark to figure it out. Instead, we ended up with a solution where the team was able to share information with me so that I can manage it going forward, but also they're an extension of our existing relationship with Domo. So they don't go away just on the last day. They're there to answer my questions and help along the way. So what are our key takeaways? Clean your data. It's not clean enough. You think it is? Clean it again. Choose the right model. Not every model is the right model for your solution, and not every model is going to be something that you can explain to your end users in a meaningful way. So always keep that in mind. Choose a robust platform. Almost everybody in the room's already got Domo. That's a robust platform where you can do all your work, right? And make sure that you're driving insights and actions. You don't just want to have a solution that's sitting in a file cabinet somewhere. You want to have a solution where you can take action and actually pull the levers, even if it's not talking about retention, even if it's a marketing use case or a product use case. Just make sure that you're being actionable and driving insights. So we've only got like a little bit of time left, but any quick questions? We can probably stick around in the room for a minute. Looks like we got a ton. We got right up front. Not sure who was first here.
Can you talk a little bit about the learning to fish and how well it prepared and what was involved and how heavy the lift was in order for you to be able to execute this on another use case?
Yeah, I think, like I said, part of it was having like a really awesome team, right? So what they've done every step of the way is explain everything to me in detail, almost like going to school. We spent half the time actually working on the project, and the other half of the time discussing the whys and hows of it. So it was like an extremely hands-on learning experience. And we were really clear up front that we wanted to learn. We didn't just want this to be a typical consulting engagement. So it was just a critical hands-on portion all along the way.
I have a question. I know the data is focused, like you guys said, data. But I'm just curious, like usually you can predict how many people. you can usually predict how many people are going to leave, but I saw you guys had specific names, right? Which is something that's pretty difficult to do. Like, what kind of indicators do you look at to know, like, oh, this specific person is the person that's going to leave versus we're going to have 20 or 25 people leaving this month or next month?
Sure. So again, I can't talk, like you said, about specifics about our organization. But one thing that our organization is, full disclosure, a little bit more concerned with the aggregated results than the individual results. But those aggregated results are driven by row-level results. So I don't know if you could maybe give a better explanation of it, but essentially, we're feeding the model row-level employee data, and we're using that to drive our predictions. So in the end, we have row-level data as an output.
And if it helps at all, we generate an equation, and then all of the information on your test data, the data that doesn't have an outcome yet that you want to predict, you just use all of those values, feed them into the model, and it gives you a result. So, and then basically a parameter around that result to the degree to which we think it's going to be effective or not, if that helps.
Yeah. Just super quick way to explain it. If person A shared the following 50 attributes, and they terminated after 3 years, and person B shares the same 50 attributes, we can predict that maybe they'll have a similar result.
Yeah, so it looks like you guys put together a linear regression. One of the things you said on your earlier slides was that you make no assumptions, but it seems like you made a lot of assumptions in the imputation phase. I guess my big question is regarding why you decided to use accuracy to measure model performance. Especially for regression, it seems that you'd want to use a loss metric that actually takes into account how wrong you were when you're predicting an employee. If you predicted 20 months instead of 1 month off, you should be able to measure that as part of your model performance.
So Christy can probably give a more technical explanation, but one thing that we did do is we ran way more complicated models than a linear regression, and we ended up with like really similar results. So we ended up, for simplicity's sake, using a model that we could explain the accuracy of to other people. But you could probably add a little more color to that.
We looked at 2 different ways to structure the data, and within those 2 different branches, we ran between 6 and 12 models. And we picked the one that was both the easiest to understand and the easiest to communicate to others, and we did not give up anything in terms of accuracy when we did that.
Right, but when you chose that model, you decided to use accuracy as your metric for model performance. Isn't it bad practice to use accuracy as a metric for a linear regression?
Accuracy in cross-validation?
Accuracy, because you were saying that you got 73% accuracy, right? But
during
your
cross-validation,
actual model's
right.
predicting months, right? So you're not measuring the magnitude that you were wrong.
Perhaps we should talk later. I hope that it's understood that when we're talking about accuracy, we're talking about cross-validation. So we're not talking about accuracy in predicting outcomes that haven't happened yet, if that makes sense.
Maybe we can chat after.
Yeah, so perhaps we should talk later.
Hi, I'm just curious, how many man weeks went behind the project?
Can't hear, where's the question coming? Sorry.
Hello, I'm curious as to how many man weeks, how long the project took to do?
So because we included all this education as a huge, huge piece of it, I'd say probably including start to finish, prep time, all that extra work we put into data preparation, what was it about 6 months? 5 to 6. 5 to 6 months in terms of, day 1 to delivery.
Yeah, I have a question about when you were sliding back and forth the percent bonus thing, that one page. Yeah, was that what was that in Domo? That wasn't a card, right? What was that?
That's a custom app. So in Dev Studio, you can build custom apps and you can use your controls. So what we basically do is we take the model outcome, which is basically an equation, and then each control signifies a coefficient. So you plug that value into the coefficient or the equation, and that in turn gives you the months which we're trying to measure. Does that make sense?
Yeah, it does. Thank you.
Yeah, I'll go ahead. John Paul, are you actually updating like all the R code yourself and maintaining that, or are you kind of relying on Domo and its existing engagement with you guys to do that?
So at this point, it still hasn't been completely handed over, so these guys are managing most of the R code. But as part of that education and that continuing education, they're making sure to keep me informed so that in the end, I'll be able to manage it myself. And then I've done a lot of, so far, fake it till you make it, a lot of Stack Overflow and cheating, which is surprisingly helpful.
Hello. In the what if scenario, speaking to those sliders, if you were to toggle, say, 2 of them at a time, is that just additive or do they interact with each other? Do you know what I mean?
Yeah, that's additive. So if I were to, I know I just demoed using one variable at a time. You can play with multiple that are available there at a time, and it'll plug all those values in and calculate the
And it
value.
just adds their effects? They don't have interactions?
Both the model outcome, the equation accounts for the interactions, so
Oh,
the
okay.
coefficient has accounted for it already.
Okay.
So if you just plug in the values, it'll all accounted for it. It'll give you the overall outcome result.
So the model that it's using accounts for those interactions. So it's not additive. Or it could be, depending on the interaction.
It could be depending on the outcome. So for example, let's say one of the variables had a coefficient of 0.2 and the other had a coefficient of 2. So when we say it's all interactive, so if you plug in the variable that had a coefficient of 2, that is going to have a bigger impact than the one that had 0.2. But it would all be additive, I guess. I think Christy might be able to.
If you're talking about statistical interactions, we did not include any statistical interactions in the final model, so you can't model them in the app, therefore, because we didn't measure them in the model if you're talking about that.
Okay.
I had one on the what if. You had 3 parameters, right? What about vacation? Isn't that an important parameter? If you increase vacation days for the employee?
Sorry, where's the question
Oh,
from?
oh yeah, those were just some really quick random examples with like completely random data. But there's, in the end, we're not just feeding a small number of variables, into the model. We're accounting for quite a bit of things based on, at the very beginning I talked about, hey, base your data science initiative on the theories you already have and expand on that, right? So if you think in your own company, if there's a theory going around that increasing vacation time will improve retention, then that's definitely something you should include in your model.
Thanks.
So just piggybacking off of that, I'm wondering if you guys, and I'm sure you might be disinclined to answer this, but can you talk a little bit about variable importance? I don't know if you want to disclose what were some of the top variables put in, and I'm also curious if you guys brought in external data, right, to engineer features that were meaningful to your model.
So I cannot answer the first part in any way, shape, or form, unfortunately. And to be honest, I wouldn't want to anyways, because even if it wasn't confidential information, it's going to vary so wildly from company to company and from industry to industry, market to market, et cetera. So can't really talk about that. But as far as, can you repeat the second part of the question? That I could answer.
I guess I'm curious if you guys brought in external data, and I'm sure Domo probably want to talk about how they might have done that, right?
Yeah.
With their connectors and yada yada.
Yeah, so outside of our own HR data that we pull from a bunch of different places, there's external data that we already had in Domo for other purposes, like industry benchmarks that your company may already subscribe to all kinds of different data services that tell you how much people are typically paid in your industry and your geographic location. So we had a lot of information like that we are including in the model, yeah.
All right, does this work? Okay. I believe we're out of time, but the 4 of us will be available. If you want to come up and ask individual questions, we're going to stand near the door and help you out. Thanks so much.